Hi, for this session we are looking at prime factors and factor trees. Another way of putting this together is calling it prime factorisation. Now, prime factorisation and drawing factor trees involves working with composite numbers. So just to recap, composite numbers have more than two factors, so 3 or 4 factors. Our counting numbers are made up of either composite numbers or prime numbers. So we will see both composite and prime numbers in our factor tree. Okay, before we continue with factor trees, let's just do some pre-skills because we'll need to use these skills when working with factor trees and showing prime factors. So I want you to simplify the following. Have a go first. Okay, so when we're asked to simplify something like this, it means we are simplifying it in index form. It can ask us to write it in index form. Or another keyword is index notation. So whenever you see that, simplify by writing in index form or index notation. This is what we're going to be doing. Or sometimes it just says simplify. So it assumes that you know what to do. Now, to simplify these, I want to write them in index form. In other words, I need to start seeing some powers. And because I am multiplying everything, we can see multiplication in between everything, I can do this. And this is where powers come in. So with the first one, look at the different numbers that we have. Well, we only have 2. 2, 2, 2, 2. So the whole thing has 2, and that is my base. So the only base that I have here is 2. Okay? And the next step is to just count how many 2s are there. So 1, 2, 3, 4. And that is what makes my power. I have 2 to the power of 4. Another way of looking at it is we can use the first index law. Now, if you haven't learnt it, that's okay. All you need to know is there is an invisible power, 1, above every number. In this case, it's above all of our 2s. 1 there and a 1 there. And all we're doing is, if I've got all these 1s here, how do I make all of these 1s equal 4? I just add them. 1 plus 1 plus 1 plus 1 gives me my 4. So that's actually what is happening when I write my 4 down. Okay, with this one down here, I have 3 times 3 times 3, and then the base changes, or the number changes. I've got 5 times 5. When you have more than one base, you just write down the different bases you see. I've got 3, I've got 5, and in between them, you just write down times, okay, multiplication. It's in between everything and just write it there. And you can see why. If I just write 3 and 5 like that, it looks like 35, okay? So it's important to write times there. And now do the same thing as the top. Only add the powers of the same base, the same number. So starting with my base 3, I've got 1 plus 1 plus 1. So 3 3s, 1 plus 1 is 3. So 3 to the power of 3. With my base 5, I can see there are 2 5s, or 1 plus 1. 1 plus 1 is 2, or 5 to the power of 2. Okay, so that is how we write this in index form or index notation. And you'll need to do this when working with factor trees. Now, please make sure you have read through this information here and written down the important notes. So using a factor tree to find prime factors. So we're going to go through these steps with our example, but please make sure you read through this and get a head start. And please write down the important notes. Okay, so a factor tree, if you're wondering what it looks like, it's something like this. I guess it's called a factor tree because it's got branches that look like a tree, I guess. Now, the other keyword that we have to know is prime factors. Okay, prime factors, we can see the word prime, which is referring to prime numbers, and factors are factors of a number. And that's what it means. So if we go back to a previous example, it says write down the prime factors of 14. So first, write down all the factors of 14. We've got 1, 2, 4, 7, and 14. And our next step is, okay, write down the factors that are prime numbers. Well, out of these numbers, I know 1 is not a prime number. 2 is a prime number. 4 isn't. And 7 is a prime number. So the prime factors of 14 are 2 and 7. So that's what we mean by prime factors. Factors that are prime numbers. Now, our question here asks us to write 120 as a product of prime factors using a factor tree. Okay, so we just looked at the keyword prime factors, factors that are prime numbers. Products, remember, whenever you see the word product, you think of multiplication. Product is an answer when we multiply. And factor tree, we looked at the example over here. A factor tree is like an algorithm that we use to break down a composite number, okay? So it's very important to understand what the question is asking you. So write 120 as a product of prime factors, and the tool we're using is a factor tree. And we'll understand this more when we do the problem. Now, before we start, if I look at my example here, if I have a factor tree of 40, so we can see 40 is on top, and then we have to pick any factor pair of that number and multiply them. And we can't use the number itself, and I'll explain what that is. So with my factor tree, I'm going to have 120 on top. Now 120 is getting quite large. A trick is, I know 120 is even. So straight away, a factor pair would be 2 times something, or half of 120 to give me 2 times something to give me 120. Well, I know 2 times 60 is 120. So if that helps, do it that way. Or if I use my timetables, I know that 10 times 12 also gives me 120. It's up to you which factor pair you use, but you cannot use 1 and the number itself. If I put down 1 and 120, and I try and break down 120, I'm starting from the beginning. I've got 120 here and 120 again. I won't get anywhere. So that's what we mean by you cannot use 1 and the number itself. Now, I think I might use my 10 times 12. Now, I like to write times in between the numbers. You don't have to. And most factor trees don't have that. But if you find that useful, please go ahead. Now, the next step is to keep breaking down our composite numbers, and our branches stop when there is a prime number. Okay? So we only stop when we see a prime number. Now 10 and 12, they are both composite numbers, not prime numbers, because I know, yes, 1 times 10 gives me 10, but also 2 times 5 gives me 10. Okay? Now, can I stop here? Yes. 2 and 5 are prime numbers. I can't break them down any further. There's no point in writing 1 times 2 or 1 times 5. It's the same thing. Now, if I move on to my 12, 12 is a composite number. So there are other factors. I know my 12 timetables. So, for example, 12 is even. So 2 times 6, half of 12 is 6. So 2 times 6 is 12. Now, I can see 2 is a prime number, so I stop there. And what else I can do, and that was in the previous slide, is once you've reached a prime number, you can circle it, just to highlight that your tree stops there. Okay, I like to circle it. You don't technically have to, but it's a good idea. Now, 6 is not a prime number. It can be broken down further. Just change my color again. Okay. Yes, 1 times 6 is 6, but also it's even. So 2 times and half of 6 is 3. So 2 times 3 is 6. Now I can stop because 2 and 3 are prime numbers. Okay, and I'll circle those. So there is my factor tree for 120. Now, if you're wondering, well, what if I used my other factor pair? What if I used, because before I said I know that 2 times 60 gives me 120. Well, I end up with the same prime numbers at the end. Let's have a look. 2 is a prime number, so that the branch stops there, but 60 is not. So I can break down 60. Once again, 60 is an even number. So 2 times half of 60, which is 30, gives me 60. Easy. Once again, 2 is a prime number. I can break down my 30. I know that 5 times 6 is 30 from my timetables, or 2 times 15 because 30 is even. I might just stick with 2. So 2 times 15 gives me 30. Prime number is 2, so my branch stops there. And 15, I'll just squeeze it in, can be broken down further. Now 15, I know that 5 times 3 is 15, or 3 times 5, doesn't matter which way you write it. So 3 times 5, and guess what? I can stop there. And luckily I can because I haven't got much room. So 2 is a prime number, 2 is a prime number. So is this 2, that 3, and that 5. There are my prime numbers. So have a look and compare. Have we ended up with the same prime numbers? Yes, I have 1, 2, 3 2's here, 1, 2, 3 2's here. I've got a 5 as a prime number, just one, and there's 1 5 there. And I've got 1 3 as a prime number, and there's the other one there. So we end up with the exact same prime numbers. The tree might look different, but our goal has been reached in both of these. We've got our prime factors. Okay, now if we go back to the question, it says write 120 as a product of prime factors. We've done our factor tree. Let's understand what this means, a product of prime factors. Now, if I get my prime factors, and I can see I've got 3 2's and a 5 and a 3, product means multiplication. So I'll grab all of my prime factors, so the factors that are prime numbers, and I have this 2, and I'm going to multiply them times 2. I've got 3 2's, so 2 times 2 times 2, that one there, that one there, that one there, and then times, I'll put my 3 next. We try and do it in ascending order, from smallest to largest, and then my 5. Okay, now if I go 2 times 2, which is 4, 4 times 2, which is 8, 8 times 3, which is 24, and 24 times 5, well, 24 times 5 gives me 5 times 4 is 20, put the 0 down, carry the 2, 5 times 2 is 10, plus 2 is 12. It gives me 120. That's what we mean by that term in our question. Write 120 as a product. So 120 is the answer of prime factors. 120, we can see it's a product. It equals 120. Product is the answer. When we multiply, what are we multiplying? We are multiplying our prime factors. These are all of our prime numbers that are factors of 120. And we just checked. When I multiply all of these, it gives me 120. That's how we know our factor tree is correct, but that's what we mean by the question, a product of its prime factors. Now, we haven't finished. We're almost there. What else we need to do now is simplify these using our knowledge of powers. And you remember we did those pre-skills before? Well, I can simplify my prime factors to give me this. I've got a base 2, I have a base 3, and a base 5. They are my different bases. Now, with my base 2, there are 3 2's. So 1 plus 1 plus 1 gives me 3. Okay, so 2 to the power of 3. I have simplified. Instead of writing 2 times 2 times 2, I can just write 2 to the power of 3. Now, 3 is just on its own. So I've written 3 once, it just stays like that. And the same with 5. There's only 1 5 there, and there's 1 5 there. That is our final answer. Okay, so what we have done is we have broken up our composite number using a factor tree. Our factor tree, the branches end when we see prime numbers or prime factors. Once we have all of our prime factors, so all the branches end at a prime number, we write them down on one line using multiplication. So 2 times 2 times 2 times 3 times 5. We do a check. Does this give us the number we started with? In this case, yes. Then we have to simplify, okay? By using our knowledge on powers and index form, index notation, simplify that, and we are done, okay? And please make sure you've written down these important steps as well. Let's do one more example. Okay, our last example for this session is write 45 as a product of prime factors using a factor tree. So now we know exactly what to do. Please have a go first and make sure your final answer is simplified. Okay, I have 45 on top. Now, start off with my 2 branches. Now, I've got to think of factor pairs that give me 45, and I can't have 1 times 45. Now, with my timetables, I know that 9 times 5 is 45. Also, if you might have thought of, okay, 3 times 15 gives me 45. Okay, you pick whatever you want. We know that either one will work, or any other ones you may have come across. So I'm going to stick with my first one, 9 times 5. I might write my 5 down first because I can see 5 is a prime number, okay, and my branch stops there. So if it helps, you can circle as you go. There's my prime number. Now, factors of 9, well, 3 times 3 is 9. There's nothing else other than 1 times 9. And 3 and 3 are prime numbers. And guess what? I stop. Okay, I can't break down 3 anymore because they're prime numbers and my branches have ended at a prime number. Now, the next step is to write down our prime numbers on one line with multiplication. Okay, and let's check, is 45 a product of these prime numbers, these prime factors? Let's have a look. 5 times 3 is 15 and 15 times 3 is 45. So yes, it works. Now, simplify. 5 times 3, they are my 2 different bases. I have 1 5 there, so if it helps, you can show it. I still have 1 5 there. But here I've got 1 3 there and 1 3. And 1 plus 1 is 2. So that's my final answer. 5 times 3 squared, or 3 to the power of 2. That one we know can be invisible. Thank you.